Welcome to Xamarin University and our class SQLite and Mobile Data. My name is René. In this class, we will talk about where to store a database. We will see that this is different per platform. We have to discuss the different locations in the file system. We will then integrate the SQLite database within a Xamarin Forms project. And of course, we want to perform SQL operations on that database. We'll learn how to read data from the database, how to write data back. And of course, we will have to see how to define the schema of our database. Every device has got its own preferred storage location. We need this in order to store that file that represents our SQLite database. We want to dive a bit into SQLite, see how it is a cross-platform database system, how we can incorporate it. We will then discuss the importance of asynchronous methods, because often database operations, they are one of the things that take a bit longer compared to other maybe CPU-based operations. So I want to make sure that our app remains responsive. And by the end of this class, you will know what the preferred storage location is for a local database file. You will also know how to incorporate SQLite into your Android, iOS, and Windows applications by using an open source SQLite portable class library, which is called SQLite Net, and how to talk to that database and the tables that are in there. Our first step is to figure out what the most appropriate storage location is for our database, depending on the platform that we are working on. We will discuss that different devices or different platforms, they have got file systems that are, well, very differently structured. And every vendor has got its own idea of where specific files should go. Before we dive into the internals of the file system though, and where to put our database file, let's get one step back. It is not absolutely necessary that you have a database at all in your application, because all of our dominant platforms, they have got dedicated APIs that allow us to manage user preferences. This is really great for simple key value pairs of data that we want to store as part of our application. In fact, if you're working with Xamarin Forms, it also offers a persisted dictionary. You can access that via app.current.properties. You can of course also store data directly in the file system. Every platform has got a fully featured file system. It's very powerful. In fact, it's very fast because all the devices, they have got flash-based disks for storing huge pieces of data. It's always recommended to put these directly into the file system and not store them in a database. But what if your data needs to be queried? What if you need random access to it? Well, then database is your best option. It's just important to think about how you store data before you're getting started. Let's have a look at preferences a bit more. All three platforms, that's iOS, Android, and Windows, they have the concept of preferences built in. That means we can store simple pairs of data, key value pairs, and retrieve them while our application executes. These are really great for small amounts of data, like little integers or strings. Like if you have a feature that allows your user to remember the username on a login screen, that would be something that goes into the preferences. As mentioned before, for Xamarin Forms, we've got something built in. It has got this properties bag, this properties dictionary that you can use. Now, what if you want to use something that works across all platforms but without Xamarin Forms? Well, one of the options here is, for example, the plugins collection that we have here at Xamarin. And one of them is a plugin that allows you to work with settings. You can see here how this cross settings plugin, it has got a singleton, the current property, and there you can get a value or save one. Behind the scenes on Android, this is using the shared preferences. On iOS, it's using the NSUser defaults, and on Windows, the application data container. Now the file system is very powerful. It mirrors the capabilities of the large desktop cousins, and each platform has got a file system that is hierarchical, that has got a directory structure of folders and files. And of course, we can store our data in there. So whenever you have large binary data, or maybe you receive a JSON blob from some web service, you can store this in there. And we have to discuss the file system a bit more because we will have to figure out where to put our database file. Working with files is not really hard. You can use some of your old friends in the System.io namespace. For example, here we see how we're opening a stream reader to read a file from our app folder. Maybe we're working with a text file here or an XML file. One important note here is the classes shown here are available to the platform-specific projects. If you're still using a portable class library, then they are not directly available. You will need some helpers, some abstractions. If you're using a .NET Standard library, it's different again. There we get access to the file system on all platforms. When deciding the file format to use, you should consider the type of data that you're dealing with. You should ask yourself, well, how much data do I have? How big are these files going to be? What type of data is it? Is it binary? Is it text-based? Does it have some sort of parent-child relationship in there? And the answers to these types of questions, they will lead you to an appropriate choice for representing the data itself. And if, for example, your decision is that you want to go with XML, well, then you can read that using XML document as shown here. When you work with files, there are actually a couple of places where they can go. First, when the app is installed, the app will be placed in a certain location on the device. And this location will be specific to the type of operating system that you're running on. One important thing here is that there are APIs that you can use to read from within your application package or bundle. So by doing that, you can, for instance, access the images that are shipped as part of your application or other data that you included in there, any type of resources. Everything you have inside this package is, however, read-only, so you can't write there. What if you need to generate some content, or what if your user generates content that you would allow them to store? These files would go into the application sandbox. The sandbox is a private area that your application can work with on the device. And by default, no other application can access this area, besides the operating system, which always has access. But all other applications, they are protected from each other. And within this sandbox, we always find the same structure, the same hierarchy. That is for every application on a given platform. The structure itself will, however, be different depending on the platform that we're working with. What you see here on the screen is a screenshot of what it looks like on iOS. In the very left column, we have got all of our applications, and within every application subfolder, we find folders that are named Documents, Libraries, StoreKit, TMP, and so on. And you can find here that, for example, in the Documents folder, somebody has stored ping images. The Documents folder on iOS is, for example, there to store content that was generated by the user. And particularly Apple can be a bit picky here. They have got very strict rules that define what type of file should go where. To get to these locations, we have to understand what the file system looks like. Now let's assume we want to store a database file. A database file is something that is not user generated, but it's not something that is read-only either. So we can't put it in Documents on iOS, we cannot include it into our app package. We need to generate that file the first time our application is running. On Android, it could go into the Files folder. Android also has a dedicated database folder, but you're free to decide where you put that file. On iOS, on the other hand, Apple is very strict. They say a database file that should go into a subdirectory under the already existing folder Library. The reason for this is that every subfolder on the library will be included in the backup if the device is backed up. And also the content in there will not be removed if the operating system is running low on space. For Windows applications, UWP, we would put our database into the local state folder. In order to get to these locations, you can use the environment.getFolderPath method, which is available for iOS and for Android. On Windows, we are dealing with the local storage, so it's a different API there. Let's go through this step by step. To get to the folder that represents personal documents, these are documents that are user-generated, we can use the getFolderPath method and pass in the special folder .personal. We already have achieved our goal on Android, but for iOS, we know we have to go into the library folder, and that means we have to go one level up. So we combine the found personal folder with ... that means one level up, and then append library, which takes us into the correct target folder. There we would then create a subdirectory and place our file. Now what about Windows? On Windows, the path is windows.storage.application-data.current.localfolder.path. Of course, besides these .NET APIs that we have just seen, every platform also has got native APIs to work with the file systems. Generally, you won't use these too often. There are, however, scenarios where it's necessary. iOS, for example, requires you to work with these APIs if you would like to exclude files from being backed up, or you're downloading a file in the background. That's also an example where you need to use the native NS File Manager to copy that downloaded file eventually into your application sandbox. Let's recap this first part with a little flash quiz. Question number 1. To retrieve the path to the root folder of the local data store within a UWP app, we use A, the environment.getFolderPath pointing to the personal folder, or B, environment.getFolderPath and pointed to local folder, or are we C, using windows.storage.application-data.current.localfolder.path? The correct answer here is C. UWP is the only platform where we have got different methods compared to the other platforms in order to access the file system. Number 2, the recommended location for your data file is the same across all platforms. Is that A, true, or B, false? That's false. Every platform has got a different file system hierarchy, and we need to pay close attention where to put our files. Number 3. In our Xamarin iOS app, we should always place content generated by the application within the Documents folder. Is that A, true, or B, false? And that's again false. Answer B is correct here. The document folder is meant for data that is user generated. A database is nothing that the user generates. It's not that your user runs the application and taps a new button and then says, yes, I want to store my database folder. That's not happening. The database is generated as part of the application flow, and as such, it has to go into a subfolder under library. Now it's time to work on the first exercise. Please switch over to the exercise instructions and work on lab number 1. When you're done with the exercise, return to the video and continue. Now that we have figured out where we will need to store a database file in each of the 3 available platforms, let's move on to actually integrate a database into our applications. In order to use SQLite within our Xamarin Forms app, we will need to add a NuGet package that provides the appropriate API calls to the database. We will then discuss how we can create tables using mapping through attributes, and then wrap up this section by walking through how to create and connect to a SQLite database and perform basic read and write operations. The database system that we are going to use is called SQLite. SQLite does not run on a server and requires no configuration. A SQLite file is stored in the local file system, and all reads and writes are performed directly against this SQLite file on disk. The file format that is used here is cross-platform. This really makes it ideal for our different platforms. SQLite is natively included on Android and iOS, and also the latest version of Windows includes it, which is really nice because it means this database is available on all platforms that we would like to support. The built-in SQLite engine supports a C or C++ API. We have to pick a third-party library that provides a C# API to access the SQLite database. There are actually several to choose from. We can either use the mono libraries that use the old ADO.NET style, which is not really a preferred approach anymore. We can use a wrapper provided by Microsoft, the portable class library for SQLite. We can also have a look at Entity Framework Core, which is open source and falls into the category of ORM, Object Relational Mappers. If you're interested about Entity Framework, we have got a lightning lecture online on our university website, by the way. And then finally, there's SQLite.net. This is a library developed by Frank Krueger. It's an ORM implementation that is very easy to use and is the approach that is favored among developers. Let's compare the approaches. Each of them has got several pros and cons. ADO.NET is really well known, relatively easy to work with. However, it's going through a few layers of abstraction here, so it's the middle of the road performance-wise. The Microsoft Portable Class Library for SQLite is really a very thin wrapper around the C++ APIs. Documentation is fairly minimal. It supports iOS and Android, but no UWP support. SQLite is really the most common approach being used today. It's easy to use, supports all Xamarin Forms environments, it's very stable and widely used. Using object relational mapping simplifies the process of defining a database schema because it allows developers to use the models that are already defined in their project and they will serve as the schema. The database schema is identified through the use of attributes, which we will discuss more in the next slide. SQLite.net is shipped as a NuGet component. We will have to add this component to each and every of our project. That means in Xamarin Forms, we add it to the Xamarin Forms project itself, and then to the iOS, the Android, and the UWP project. Be careful, there are several implementations out there and branches of this package. Make sure to pick the right one. It should have a single author named Frank Krueger. When you add this component to your project, additional components will be installed. SQLite.net PCL is the core assembly that is included, and it contains all the classes to support and identify the data entities that will be saved and restored from the database. It's also giving us all the high-level classes that we will use to create, query, and work with those entities. Then we will get additional bundles, like the SQLite PCL.bundle-green. It contains a compiled copy of the SQLite library for platforms that don't include the runtime natively. This will show as batteries in the references folder. And then we have a third component, that SQLite PCL.raw basic. This is added to your project to provide the raw C# wrapper around the C and C++ APIs. This is used by the core assembly to access the database engine. And unless you need to talk to the underlying API for some reason, you can generally ignore this component and just let it do its work. Let's switch over to Visual Studio. I want to see how to add SQLite.net to our Xamarin Forms project. Here I have opened the solution that you were working on in the first exercise. By selecting our solution entry here in the Solution Explorer and right-clicking, we can find Manage NuGet Packages for Solution. This will bring up the NuGet Package Manager, where we first see a list of all the packages that are already installed. Up here, we can switch to the Browse tab. Once activated, we can start searching for the NuGet package that we would like to add. This is called SQLite-net-PCL. As mentioned before, there are quite a few packages matching that name. We have to make sure to pick the right one. You see, here's the one by Frank A. Krueger. In Visual Studio for Windows, we can then just tick this checkbox here, and it will install the package into all of our projects for the actual Xamarin Forms project, the Android project, for iOS, and for UWP. Let's click the install button and installation will begin. Visual Studio is informing us here about the changes that will happen. Once all packages have been installed, we can check here in the Install tab and see that SQLite Net PCL is now here. With the packages in place, it's now time to start talking to our database. SQLite.net establishes a connection to the SQLite database through a SQLite connection object. When you instantiate this object, you must pass in the file name for the database file. And now it makes sense that we discussed the file system earlier, because this file name will point to a specific folder, and that is specific to the platform that we're on. There are two forms of the constructor. Generally, you just want to pass in the file name, but there are two other flags that you can control. The open flags allow you to control the underlying operating system file handle characteristics. For example, if you only intend to read from the database, you can note that and possibly get a performance boost from the operating system. Keep in mind that changing these flags could have different effects on different platforms and that not all flags are supported everywhere, so thorough testing is required. The other option is store datetime as ticks. This decides how date and time objects are persisted to the table. You will most always want to store dates as ticks in all new projects, and otherwise they would be stored as strings. One question that often comes up is how to manage the connections to the database. Some will advocate that using a single connection, caching it off and keeping it open while the app runs is the recommended way of doing it. Others prefer to open and close the connection as necessary. The reality is that the approach you take is really a trade-off between performance and memory. Each connection to the database is really a file handle in the operating system. These are scarce resources. You only have so many of them, and it also takes up memory in your app, primarily due to a cache buffer. Opening and closing the file is expensive. There's a lot that happens when we open a file, so it makes sense to hold the file open, but maybe not forever. We'll talk more about managing connections and threads a bit later in the class, but a good approach to start with is to create the database connection and then keep it open for a certain amount of time. You can achieve this by using a database connection holder or a factory as shown here. It will create the connection and cache it. You then use the connection for a set of queries, and when you're done, you call dispose or close on the connection and set the shared property to null, so it's being recreated when you request it again. In order to create tables in our database, we take advantage of attributes that we apply to our model classes that already exist in our application. SQLite.net will use this information and turn our models into appropriate database schemas. The first attribute that we see here is the table attribute. This can be applied to a class and tells the ORM, that's the object relational mapper, that this person class here should be stored in a database table called people. Other examples of attributes are the primary key attribute, which says this identifier here should be used as a primary key at database level. And we want to map this information stored in a column called ID. Another example is the max length attribute. Max length allows you to constrain or apply restrictions on the data being stored. Besides the attributes that we just saw, there's others. For example, you can set an index on a property. Or you can say that a certain property should be ignored by adding the ignore attribute. You should refer to the documentation of SQLite.net for a list of all the properties. If our model objects are transferred over to the database, somehow data types have to be mapped. There are no real surprises in here. Integers, long values, they map to integer and big int. Floats, doubles, decimals, they all map to real. The only thing that is maybe not immediately obvious is that a Boolean value is mapped to an integer where 1 equals true and byte arrays are mapped to a blob. With our model objects being decorated, we can use the SQLite connections create table method, and we pass in the type of the class that we would like to create. This will instruct SQLite.net to create a table inside the database. Now what happens if the table is already there? Well, there's some bonus. It will try to upgrade the table. That means if you add a new attribute to your model object, it will add the additional column. Please be careful. It will not try to remove any columns. So the support here is limited. Once our table has been created, we can use the insert method on the SQLite connection instead and pass in an instance of the class containing the data that we would like to store. Whenever we call our insert method, it will return an integer value. That integer value will tell us how many rows have been inserted. If you try to insert one person object, this should typically result in 1. If the result is 0, that tells you that something went wrong. To retrieve records of a table, you can use the table method. Again, this can be found on the SQLite connection. With the table method, you instruct the ORM to look at the table that is mapped to a specific model object. However, table alone does not execute anything. You have to instruct it what to do. If you would like to get the entire content of the table, you would use the toList extension method. Now careful, if you're using toList, it means that it's reading the entire table. If you have got a lot of records in there, you can easily run out of memory. After the next exercise, we will learn how to filter results so that the amount of records that is returned from a table is limited. In the next exercise, you will create a database, create a model object, map it to the database, and write some data to the database and read all the data back. When you're done with the exercise, please return to the video. In the previous exercise, you read the entire table content back into your application. Often that's not what we want. We add a database because we want to be able to query our data. LINQ, or Language Integrated Query, is a component that is built into the .NET framework, and it allows developers to perform queries on any data source using a combination of extension methods, query operators, and Lambda expressions. LINQ can be used to access SQL databases. It can also be used to read XML files or data from other resources. In SQLite.net, LINQ supports the management of queries, and it allows us to return data from the underlying relational database by using objects. The table query class is important here. This is what is getting returned by our table method that we just used in the previous exercise. SQLite.net has support for common LINQ operators such as where, order by, count. These all get evaluated and turned into the equivalent SQL query. So it's important to understand that if you want to get all the records starting with a specific letter from the persons table, it's not loading everything and then does the filtering in the application, but instead the filtering happens already at database level. You can use the LINQ syntax as shown here, or you can use the extension methods. It's completely up to you. The result will be the same. By the end of the day, your LINQ expression will be turned into an actual SQL query. SQLite.net actually generates parameterized queries. So what you see here on the right-hand side is really a simplification. But it shows that if you write some .NET code, it will be translated into SQL. SQLite.net also supports common string and array operators. For example, contains, start with, ends with. All of these are turned into a variation of the like statement that we have in SQL. Here you can see an example. We're using the starts with on a property which is mapped to a column. This will be translated into a like statement in SQL. Let's do another flash quiz to recap this part. Question number 1. Using SQLite Net, which of the following creates a connection to a SQLite database? A. New SQL connection using a path as a parameter? Or B. New SQLite connection with a path parameter? Or is it C. New SQLite connection with a target platform and a path? Or is it D. A new SQL connection with a target platform and a path? The correct answer is B. You're creating a new SQLite connection, and typically you will only pass in the path unless you want to control additional underlying file system behavior. Number 2, mapping a table to a class is done using which attribute? Is that A, the table attribute? Or is it B, the entity attribute? Or C, table entity attribute? Or D, none of the above? A is the correct answer. We're applying the table attribute to a class in order to map that class to the database. Number 3, LINQ to SQLite Net. A allows you to perform queries against the SQLite database, or B translates language integrated queries to SQL queries behind the scenes, or C returns a filtered result set back to the application, or D all of the above. D is the correct answer. With LINQ to SQLite Net, you can achieve all of this. Everything we've done up to this point has been executed on the UI thread. Whether it's creating our tables or reading data from the table, it all blocked our UI. For highly responsive mobile applications, we want to make sure that any areas that may cause potential lags in the application, just something like data access operations, they are performed on a background thread. That's why we will look at the asynchronous methods that are available for communicating with our SQLite database. SQLite Net provides async methods that we can use to free our UI thread from work. It's important to keep an application responsive. Depending on the operating system that you're running, the reaction to a laggy app may be different. Particularly iOS is very strict here. It will simply terminate your app if it's not responding to user input. So we want to avoid that. Earlier we talked about caching the connection off. This is really a valid way to use connection, and it turns out that SQLite connections are thread agile. That means we can use a SQLite connection instance on any thread. However, this does not mean that they are thread safe. You can only have one outstanding operation running at any given time. Running two operations at the same time will very likely crash your app and possibly corrupt the database file. Once the database is corrupt, SQLite will throw a SQLite exception with the message corrupt. You must then delete the database and recreate it. All data is lost. The way most people solve this is to provide locking using a single shared guard object, which ensures that only one thread uses the connection at a time. You can then use multiple background threads to perform database work with a single shared connection. The good news is that using the asynchronous operations that are available with SQLite Net, we don't really have to worry too much about these problems because everything's built in. SQLite Net exposes a SQLite async connection that we can use instead of the SQLite connection that we used before. And on this SQLite async connection, we find asynchronous counterparts of all the methods that we have used so far. Here you see how we can asynchronously create a table. And again, we don't need any external locking. SQLite Net will handle this internally. On the previous slide, we just saw create table async. Of course, we can also remove a table using drop table async. If we want to access data that is stored in a table, we can use get async. Writing data is done using insert async or update async. Removing a record from a table, delete async. We can also execute arbitrary queries using query async or execute async and execute scalar async. Let's try to retrieve some data from our person table, but not block the UI thread. We'll be using the toListAsync extension method to achieve this. And because toListAsync does not return a result immediately, we have to await this return value. You can see how the await keyword here is used prior to the call to the toListAsync method. The await keyword waits for the value that is returned here to be available. However, this is not a busy waiting. Instead, the execution returns to the caller. That means the caller, which in our case is some method on the UI thread, is able to do other things until the result is available. As soon as the result is there, execution will be picked up in the next line. In this example here, that's our for each statement. The best thing about async and await is that once execution is picked up again, it will happen on exactly the same thread that it originally started from. For us, this means we started on the UI thread. We then asynchronously retrieved data, which happened on another thread. But if we continue, we are back on the UI thread. And that's why we can immediately add our returned data into a list view. We can change UI elements without really having to worry whether we have to marshal back to the UI thread or not. I highly encourage you to learn more about async and await and tasks. We have classes about async and await and the task parallel library here at Xamarin University. The next feature we would like to cover here are transactions. They ensure that updates across records are handled correctly. The properties of a transaction are that everything in there is atomic. That means all records insert successfully or none of them do. They are also consistent. That means reads are always consistent until the transaction commits. That means if a record does not exist in one read, it still won't exist if we reissue the same query. Transactions are meant to be isolated. That means changes that are made during the transaction are not seen until they are all complete and the transaction is committed. And finally, every transaction in a SQL database should be durable. That means if a failure occurs, the database will not be left in some inconsistent state. That is, if you power off the device right before committing the records, but after the final insert, the system guarantees they will either be all present or none of them. This principle of ACID, atomic, consistent, isolated, and durable, is guaranteed by SQLite Net and the transaction that it supports. You start a transaction and commit it by using the run-in transaction async method, where you pass in a delegate that contains all the SQL statements that you want to make sure are either all executed or completely rolled back. Besides this run-in transaction async method, you will also find methods that allow you to explicitly begin, commit, or roll back a transaction. This can be useful if the database operations that you are planning span multiple methods. While the ORM mapping is really nice and useful and easy to work with, it also abstracts the SQL away from us. As a result, it may stop you from pulling specific types of data out of the database. Maybe you want to perform a select with a join. For all base types of queries, the ORM system is great. But what happens if we want to go beyond it? We have the methods execute async, execute scalar async, query async, get async, and find async. They are all there and meant for lower level execution of SQL statements. Let's have a look at some examples. We can use the execute scalar async method to retrieve, in this example here, the oldest person from our people table where an ID is used that is greater than a given ID. You can see how you can directly enter the SQL statement, including parameters. As a result, execute scalar async will return the value of the oldest age, which in our case is a double. Here's another one. We are pulling a relationship out of two tables here. You can't do this directly using the ORM. We select everything from students where the identifier is used in classes that the student is participating in. The result will again be a list of student. If you try to solve this with the ORM, you would have to perform 2 queries and then combine the results in your application. One more word about async and await. When we introduced these keywords here, we learned how they greatly simplify working with tasks, particularly for UI and mobile apps. This is a real advantage. However, in some cases, the processing of data does not need to be done on the UI thread. We only need to be on the UI thread if we plan to update the UI in some way. If instead our data will be used for background processing, then it's inefficient to marshal back, which the async and await keywords do implicitly. In these scenarios, you can use configure await false to tell .NET to not return control to the UI thread after the await call is finished. Instead, you will typically stay on the background thread. Again, this is mainly here for your information. And my reminder once more is to go check out our classes here about async and await and task to learn more about these great APIs and features. And this brings us to the last exercise, where you will refactor the previous exercise and remove the blocking SQLite connection and replace it with the asynchronous version. This means you will have to change all of the method calls to the async counterparts. And because they are async, you will have to await them. And that means the usage of async and await and tasks that will bubble through all of your code. When you're done with this exercise, you have reached the end of this class. In this course today, you have learned what the preferred storage location for a local database file is based on the device that you're on. We learned that Android, iOS, Windows, they all have powerful file systems, but the structure is different. You also know now how to add SQLite to your projects, whether it's Android, iOS, or UWP, or a Forms application. We then accessed our SQLite database using an ORM wrapper called SQLite.net. Using this wrapper, we were able to use our existing model classes. We just had to add some attributes, and SQLite was able to take care of updating existing content, inserting new content, reading content back. Thank you for watching this class, and goodbye.